Welcome to qnawire.
Okay, for this question, I can teach you how to do it, but you need to do the calculation by yourself. Okay, so from the question, we know that 40 Newton force can stretch the spring by 0.25 meters. So we can know that the K constant of the spring is going to be the force divided by the distance, which is 40 divided by 0.25. Now we know the spring constant. Once we know the spring constant, the angular frequency can be calculated by the spring constant over the mass and take a square root. So this mass is what we're looking for. In question A, we know the period, which is equal to 2 pi over omega. So yeah, it's going to be 2 pi over square root k over m, right? So from this equation, we can express the mass as period over 2 pi square times k. So we know the period is 1 second. We know 2 pi. We know k from the very beginning. We can find the exact value of the mass. That's question A. And hence, you know the mass, you know k here. You can also find what's the value of the angular frequency. So for question B, we know the amplitude. So we know the amplitude. We can write the expression of the position as x equal to the amplitude cosine omega t plus phi. We know the amplitude already. We know the angular frequency, but we don't know the phase here yet. But we do know that at t equal to 0, the x equal to 0, so cosine phi equal to 0. And at t equal to 0, we can write the expression of velocity is equal to negative omega a sine omega t plus phi, right? At t equal to 0, it's moving downward. So v smaller than 0, so sine phi gonna be equal to -1 because, oh no, so it's gonna be +1 because there's a negative sign here. So v is negative omega a at this moment. This part should be 1 because the v is smaller than 0. Okay, so from this equation, we can know that phi is going to be equal to pi over 2. Okay, so we also know phi. We know the whole expression of our position. So all we need to do is plug in the number 0.35 into here, and you can find where is your object. Okay, and to what direction. So the period is 1 second, which means half of the period is only half second. So it's going to take 0.25 second to going down and take another 0.25 second to move up back to the equilibrium point, right? So 0.35 should be somewhere here. The direction moving up. The direction of the velocity is moving up, okay? Okay, so last question. So here is the equilibrium point. At the equilibrium point, the force equal to the weight, which is equal to mg. Now, the object is below the equilibrium point with distance d, right? So now, the new force F prime going to be equal to the original force plus the stretch of the spring by this distance, which is kd. This is the force that the spring exerts on the object.